evaluator is interested in determining whether there is a relationship between the student section and his or her final exam grade for an introductory course. A random sample of 500 students was selected, and the coordinator calculated the correlation R is equal to minus 0.8 between the section and the final exam grade. You conclude that. So now there is a now they are asking about the correlation between the section and the final exam grades. So student in lower number sections did better on the exam than the student in higher number section. Students in the lower number section did worse on the exam than the students in high number sections. There is a weak negative linear association between student section and the final exam grade. Correlation is inappropriate here because the relationship between section number and the final exam grade is likely to be a non-linear. It's not non-linear, it's definitely linear. Coordination made an error. So basically, the correlation coefficient for the student section and his or her final exam grade is found to be minus 0.8. And the variables that are the student section and the grades are not related because the two variables are not related. There is a because the student section is a categorical variable. And final exam grade is not the categorical variable. So because there are two different variables, this is a numerical variable and this is the categorical variable. So correlation is not possible to calculate between the categorical and a numerical variable. It can be calculated between the two quantitative variables only. So it means the coordination has made an error.
Oh, Josie.
So option E will be the correct answer that the coordination is make an error because correlation is even not possible in this case when we have two different kind of variables. So in what kind of variables do the correlation is possible? For what kind of variables correlation is positive? Possible?
And they both are categorical.
Both are
Ordinal?
ordinal? No, not ordinal.
I don't know.
Yes, when the both are quantitative, not ordinal.
Yeah.
When both are quantitative, okay? We just did it in the last multiple choice question. Okay, question number 8 is recording January 1st as a day 1 in December 31st as day 365. The manager of a 7 to 11 store records the daily slurp sales in dollars over the course of a year. The manager calculates the correlation between the day number X and the sales Y to be close to 0, which surprises her. Which is the most likely explanation for this? So the daily sale didn't change much over the course of the year, which is the most likely explanation for this. So we have to find out the best explanation. The manager made a calculation error. The relationship between the two variables is not linear. There is a lurking variable. There really is no relationship between the two variables. So what are the two variables recording January 1st as day 1 and December 31st as day 365? The manager of a 7 to 11 store records the daily surplus sales, so daily sales, over the course of the year. The manager calculates the correlation between the daily number X and the sales Y. So the two variables are day number and the daily sales, like first day and the sales, second day and the sales, third day and the sales. So the the daily sales didn't change much over the course of the year is not the correct answer, which is the true explanation. The manager has a correlation, so manager is not has not calculated the correlation. So how we can say that there is an error? The relationship between the two variables is not linear. Yes, it cannot be linear because the sales and the day number in the daily sales may not be linear relationship. This may be an exponential relationship. This may not be a linear relationship. So this option C will be the correct answer. Okay. So question number 9. Four swimmers participated in a race. The shortest swimmer finished first, the second shortest swimmer finished second, the second tallest swimmer finished third, and the tallest swimmer finished fourth. What can we be said about the correlation between height and race time for these four swimmers? So the two variables are height and race time. So as the height of the swimmers increases, may the race time may also increase because the good height people can give a good race time. But not necessary that if whenever the height increases, uh, uh, the race time always increases. It's not necessary, but it can be a positive relationship. But can it be a perfectly correlated? No, it won't be a perfectly correlated, but it is a positive. So it won't be negative, won't be negative, won't be zero. So this is a perfect correlation, or it's not perfect because it's not necessary that if it increases five inches, it will be increases in the same way. So it's not R, it's R it will not be equal to one, but this will be a positive relationship, so it will be E. So it is obvious that this is a positive relationship. So all the first three options are wrong, and it is not perfectly positive correlation. So D is not the correct option. So E will be the correct option for this. Okay. A police officer would like to determine how the number of alcoholic beverages consumed by a person can predict his or her blood alcohol level. The officer measures the values of both variables on a sample of people leaving a bar one night. The correlation between the two variables is calculated to be 0.88, and the equation of the least square regression line is calculated to be y hat is equal to 0.003 plus 0.012x. Which of the following statement is true? Okay,
Which
88%
was
of the variation in the blood alcohol level can be accounted by its regression on the number of alcohol beverages consumed. Okay, what did you answer?
D.
D. Okay, let's check. 77% of variation in the alcohol, 94% of the variation, 88. So obvious the 88% of the variation in the alcoholic beverages consumed can be accounted for its regression on blood alcohol level. 77% of the variation in blood alcohol level can be accounted by its regression on the number of alcoholic beverages consumed. So how can you calculate D?
I didn't calculate, just thought a bit more reasonable.
Give 1 second to it and try to calculate it. Yes. So in this, the regression line is given as y hat is equal to 0.03003 plus 0.012x. So it means x is the number of alcoholic beverages, number of alcoholic beverages. And what is y? Y is a blood alcohol level. So there are two variables, alcoholic beverages and blood alcohol level. Okay. So now we have to find out that which of the following statement is true. And in all of the statements, they're talking about the variation. So how we calculate variation? Variation in the regression is calculated by taking R square. So what is R? R is 0.88. What is the square of 0.88?
0.774.
0.77. So 77% of variation in blood alcohol level can be accounted by for its regression on number of alcoholic beverages consumed. So E will be the correct answer. Because for B it's 77%, but it is written opposite. Number of alcoholic beverages it is written first, but number of alcoholic beverages is the X1, so it will be written afterwards because regression is for the variation. So whenever you will see the word variation, you have to calculate R square. Simple. Okay. So it's
Okay.
0.774, which is the correct answer. It will be option E. What happens? Okay. We are done with question 10. Okay, I'm giving you 1 minute for question 11 again. Okay. Data are collected for some explanatory variable x and response variable y and the correlation r. So there are three things: explanatory variable x, response variable y, and correlation r. And the least square regression line are calculated. Which of the following statement is correct? The correlation tells the direction of the linear relationship. Now we have to tell which is false. So correlation tells us the direction and it is either positive or negative. Correlation measures the strength. The slope of the regression line tells us the direction of the linear relationship. The slope of the regression line measures the strength. So slope does not measure the strength. Sorry. So D won't be correct. The intercept of the regression line predict the values of y when x is equal to 0. Yes. So intercept is basically always when the value of y when x is equal to 0. So this is always true. So everything is true except D. So D will be the correct answer. The least square regression line is the line that minimizes. So least square regression line is a line that minimizes yi minus y hat whole square summation. B will be the correct answer. Which of the following statements about the least square regression line is true? So about least square regression line, the slope of the least square regression line always has the same sign as the correlation. The slope of the least square regression line has the same sign of the correlation. Yes. The least square regression line is the line that minimizes the sum of principles. No, it does not minimizes. The least square regression line is the line that maximizes. No, it does not maximizes. So only A1 is correct. Consider the scatter plot shown below, displaying the relationship between some explanatory variable x and response variable y. Which of the following statement is true? Point A, the red point is the residual when x is equal to 4. Point A is the residual when x is equal to 4. So is it the residual? No. This is the influential outlier. Point B, the yellow point is the predicted value of y when x is equal to 8. Okay, just look at this example for 1 minute. Check all of these points. Are they giving the correct answer or not?
Okay. B.
Sorry.
B.
B, yellow point is predicted value of y when x is equal to 8. Not necessary, there can be more predicted values of y. Point C, the blue point is an influential observation. Yes, this can be correct because what is an influential observation? I told you in the last lesson that an observation which, if we will delete this observation from our data, it will have a dramatic effect on our observation. So if the observation which is an outlier, and if we delete that observation from our data, it changes the data dramatically, is called influential observation. So option C will be the correct answer. Okay. A professor would like to conduct, okay, read it out.
A professor would like to conduct a regression analysis to determine whether a student's stat
Read it on your own.
2005.
Read it on your own and find out the answer. This question needs a bit of calculation. So please do the calculation and find the correct answer. I'm giving you 2 minutes. A professor would like to conduct a regression analysis to determine whether a student's STAT 2000 final exam score can be predicted from the STAT 1000 final exam score. She records the exam score for a sample of students who have taken both the courses. The STAT 1000 exam course have a mean of 71. So let's say x bar is equal to, now please you should know x bar is mean, matlab mean 71 and a standard deviation of 9.4, so Sx is equal to 9.4. The stat 2000 exam course, the mean is 66.2. So y bar is equal to 66.2. So I state that stats, the observations of the stats are x, and the stat 2000, the observations of the stat 2000 are y. Okay. So standard deviation of is 10.3. So SY is equal to 10.3. So these are the four values given us in the correlation is also given. Correlation is 0.84. So R is equal to 0.84. So we are given with X bar, Y bar, SX, SY, and R. So now what is the predicted increase? So we have to find predicted increase. So it means we have to find the regression line, which is equal to Y hat is equal to A plus B X. Okay. So now we have to find B is equal to R Sy over S6. So what is R? R is 0.84. Sy is 10.3 divided by Sx is 9.4. Do the calculation and find out the B. 'Yes, what is the answer? Hello, calculation for this.
0.92.
0.92. Good. Okay. Now we have to calculate A. So what will be A? A is equal to Y bar minus B into X bar. So what is Y bar? Y bar is 66.2 minus B. B is 0.92 that we just calculated. Multiply by X bar. X bar is 71. Okay. What is A?
0.88.
0.88. So now we have to find the regression line. That is y hat is equal to A plus B. X, what is A? 0.88 plus what is B? 0.92x. So we have to find predicted increase in stat exam score. With stat 1000 exam score increases by 1. So 0. This number that is with x represents the slope or the increase. Okay. So 0.92 will be the correct answer. Option E. So therefore, I said this is a calculation question, so you have to do the calculations. You see that all of the values are given in the question. We just need to put the values in our regression line and we will get the answer.
Good.
Everything clear?
Yeah.
Okay. So the question number 16, they are saying the next two questions. Question number 16 and 17 refer to the following information. Okay. So take 2 minutes, read out the questions carefully and try to do them.
Could you go down? That's it. We should go up a bit, the table. Now with the options.
That are already given. Okay, so we were doing question number 17, sorry. Leonardo da Vinci believed that a person's height could be predicted from their arm spans. The values of both variables are measured in centimeter for sample of 9 individuals. So when they say sample of 9 individuals, it means n is equal to 9. So the scatter plot is shown, arm span is on the x-axis, so it's x, and height is on the y-axis, so it's y. So equation of the least square regression line is y hat is equal to minus 8.52 plus 1.06x. So we know what is the square of regression line. Y hat is equal to b1, b naught plus b1 x. And what is the square of regression line given over here? Minus 8.52 plus 1.06 x. What is b1 equal to? b1 is equal to r into sy over sx. So it's already given that 1.06 is b1. So it means 1.06 is b1. R, what is sy? Sy is 8.05, which is the standard deviation of the y values, that is height. And sx is the standard deviation of the x values, that is arm span, which is 6.87. So when we're going to solve it, okay, solve it and tell me the answer.
We would take these to the other side.
Sorry,
We would take these numbers to the other side,
why?
like to the other side.
You're not able to see the screen?
No, I am.
Okay. So just solve this to find the value of the r. Okay, what? Okay, your question is how to solve it. Okay, so this is a simple algebra 1.06 multiplied by 6.87, because 6.87 divides here, so it should multiply there. Divided by 8.05, so which is equal to r. Okay, tell me what is the value of r now?
0.904.
So the question is to find the value of the correlation between the arm span and the height of the sample of individuals, which is 0.904 or 0.905, which is the correct answer. Got it?
Yeah.
Do people buy more ice cream when it's hot outside? Researchers collected data from 19 American citizens. So N is equal to 19. For the month of August, the average monthly temperature X was recorded for each city as well as the ice cream consumptions, while the following calculations were made. The correlation between temperature and ice cream consumption was 0.5. So correlation is represented by R is equal to 0.5. Average temperature was 74. So let's say temperature is the factor X. So X bar is equal to 74. Average ice cream consumption was 0.4. So let's say it's Y bar. So Y bar is equal to 0.4. We can name it like X and Y ourselves. Standard deviation of temperature was 8. So Sx is equal to 8. And standard deviation of ice cream was 0.16. So Sy is 0.16. What
I
is
wouldn't know which is X and Y.
We can name any X and any Y.
Okay.
No restriction. What is the predicted ice cream consumption in an American city with an average August temperature of 80 degrees Fahrenheit? So where we are going to use this 80 degree, I will tell you later. The first thing is we have y hat is equal to b naught plus b1x. Okay, so we have b1, which is equal to r multiplied by sy divided by sx. So what is r? R is 0.5 multiplied by sy is 0.16 and sx is 8. So let's do the calculations. 0.5 into 0.16 by 8, so I will get 0.01. B1 is 0.01. Okay, so what is B naught? B naught is equal to y bar minus B1 x bar. Y bar is equal to 0.4 minus B1 is equal to 0.01 and x bar is equal to 74. Yes. So what we're going to get is B naught is equal to minus 0.37 minus 0.34. Okay, this is the calculated answer. Hope your calculation works here. So y hat is equal to b naught. What is b naught? Minus 0.34 plus b1, which is 0.01 into x. So this is the y hat. Okay, this is the regression line. This is the predicted value. What is the predicted value? This is the predicted value or the regression line. Whenever I told you to find the regression line, you have to find this. Now they are saying that predicted ice cream consumption in an American city with an average August temperature at 80 degrees Fahrenheit. So it means we have to put x is equal to 80. Here this thing is going to be used. So we can put y hat is equal to minus 0.34 plus 0.01 multiplied by 80 over here. Okay, tell me the answer now. Tell me the answer now.
1 second. 0.46.
0.46. So this is the correct answer, B option. So this is not that difficult. This is the thing that we have just done in the last question. So this is very similar. Can you please write it down somewhere? Next one is can the number of calories in breakfast cereal be predicted by the sugar content? Researchers gathered the data for the breakfast cereals, including sugar content and calories per serving. So cereal, sugar, and calories. The correlation between the sugar content and the calories for the sample is calculated to be 0.84. The equation of the least square regression line is so y hat is equal to b1 plus b naught x. Is it like this or b naught plus b1 x?
B1 plus B0x, yes.
Okay. So what was b1? R into sy over sx. So what is r? Correlation is going to be 0.84. What is sy? Standard deviation, we can say this first x and second y. So 4.53 divided by sx 2.09. Okay, do the calculations and find b1.
One 1.82.
Okay, 1.82. This is B1. Now you have to find a B naught. So what is Y bar? Y bar is 104.1 minus B1 is 1.82. And what is X bar? It's 5.8. Okay, calculate this.
93.54.
93.544. Okay. So now put the value back in the Y bar is equal to B naught plus B1 X bar. So it's Y bar, which is equal to B naught is 93.54 plus B1 is 1.82x. So this is the regression line. 93.54 plus 1.82x, option A is the correct answer. Do the working somewhere on your notebook and then let's move to the next question.
Done.